Hello friends, welcome to this session in which we will discuss the technical overview of IUDX, India Urban Data Exchange. In particular, we will walk you through the technical reference architecture of IUDX, key IUDX services, and example stakeholder interactions. So let's get started. Fundamentally, IUDX is a data exchange platform that enables a seamless data exchange between data providers and consumers. It does so using open interfaces or open APIs and open data models. This not only allows easy access of data, but also makes data usable, interpretable, and interoperable. This breaks the data silos and helps unlock the immense value of available data. With IUDX, a key objective is to enable controlled and secure any-to-any exchange of all forms of public and privately owned non-personal data and not just open data. The key aspect here is that the data is access controlled and that the data provider retains all the control over who to share this data with. Smart Cities Mission and IISc came together to conceptualize and build IUDX. It's an open source effort with the source code freely available. It is a collaboration between government, industry, academia, citizens, and communities. Currently, it is deployed as a cloud service in over a dozen Indian cities with many more in pipeline, and more data is being onboarded onto this platform. Now, with a data exchange based on open interfaces, it is expected that an ecosystem should develop around it, which we call as data space. Such data spaces will be immensely valuable in achieving data smartness and generally will involve data model repositories, use case templates, application ecosystem, data governance and policy frameworks, etc. Development of such an ecosystem depends a lot on underlying data exchanges and design principles such as open interfaces, open data models become super critical. With this background, let's dig a bit deeper into the reference architecture of IUDX. Now, before we talk about the reference architecture, we need to identify the stakeholders. So IUDX identifies two key stakeholders, data providers and data consumers. Provider is an entity, human, possibly delegated by an organization or an organizational role that has responsibility to provide authorization to use its data resources. That is, as far as IUDX is concerned, we consider provider as the sole authority to say which consumer has access to its data resources. Consumer is an entity, human, organization, or an organizational role that consumes a data resource via an application, which we call as consumer app. So what are the concerns of data consumer and provider? Data consumer would like to discover data sources of interest, access data from these sources in a secure fashion, get authorizations for the data sources that are not open, and get additional context for data where available for usage in smart applications. A data provider would like to control access to its data sources, that is, create, update, delete access policies, and it expects the data to be served according to the set control policies, access control policies only. It would like to onboard data from its sources and add meta information to make the resources discoverable, and both consumer and provider would like the ease of operations. IUDX reference architecture is designed to satisfy these requirements or these stakeholder concerns. So here is the services view of IUDX. It consists of three main services: catalog service, which deals with discovery of data sources and provides additional information about data sources. It also provides the data models for the data available for that resource. Authorization service, which deals with the access control. That is, it allows providers to set access control policies and the consumers to get tokens against those policies to access a given resource. And finally, data access service, which deals with serving of the data available on the platform. It does so using standardized APIs to access data, and it also provides the data models with which the data is served. Thus, we see that IUDX connects the data sources to solution or application providers to extract full value of data, and it does so through open interfaces. Now, let us look into each of these services in slightly more detail. First, let's look at the catalog service. Catalog is essentially a meta information store for each data resource. It helps in search and discovery of a data resource using attributes such as descriptions, tags, locations, etc. It helps with data usage and interpretation with objects like data descriptors or data models, and may contain additional attributes to enable smarter use of data in applications. IUDX catalog is based on linked data concepts, and we will discuss more about it in the next slide. Catalog supports APIs for resource discovery using geospatial, text, property, and relationship search, and management APIs to create, update, and list meta information objects. IUDX uses JSON-LD to represent meta-info objects in catalog. To represent data model attributes, it uses vocabulary, which we call as IUDX vocabulary, which is based on extensions of RDF schema. And wherever possible, the data model attributes are reused from popular vocabularies such as Smart Data Models, schema.org, etc. To summarize, IUDX is a meta information store of JSON-LD documents, which helps in discovery of resources, data interpretation and interoperability, and finally, it provides additional context for smarter use of data. Now let's look at an example of data descriptor object for a given resource contained within catalog to help understand the benefits of JSON-LD as a representation framework. Consider data from two different sensors. As expected, each one is sending similar data yet with small differences. Now, what does each attribute mean? How to interpret values from each attribute, and how to relate data from two different sources. These are some of the questions that a data consumer will be faced with. This is where JSON-LD comes to the rescue. The data descriptor objects which are shown here are JSON-LD objects, and it contains the context of each of the data source using add_context directive of JSON-LD representation format. For example, in the first source, it links carbon dioxide to IUDX:CO2, thereby stating that the semantics of carbon_dioxide are same as that of the property CO2 listed in IUDX vocabulary. Similarly, for the attributes AQI and date. Further, it also provides additional information about carbon dioxide attribute itself. For example, it shows that its units are in ppm and that it is a numeric quantity. For the second data source, again using linked data, we discover that its semantics are same as carbon dioxide attribute of the first data resource, and further its units are in ppb. Similarly, the date and time attributes in the two data sources are same. So we see how JSON-LD is a natural representation format to answer each of these above raised questions in an unambiguous fashion, right? To summarize, data descriptor is one of the meta info objects present in the catalog. It's associated with each data resource. It's a JSON-LD document, and it provides the context for the usage of data. Next, we look at the IUDX Authorization Server. IUDX Authorization Server implements the IUDX specs for authorization and access policy authoring. Stakeholders, that is the providers and consumers, can participate easily in this process. It allows data sharing while respecting ownership and privacy requirements. That is, only the authorized entities can get access tokens to access the private or protected data. The main functions of authorization server in IUDX are authentication to identify all parties. We use OpenID Connect-based authentication. In the current implementation, identity services from Keycloak are used to provide authentication. Authorization to grant access to protected resources. Here we use JWT tokens. An optional token introspection point is also provided with the authorization server to validate the tokens. Finally, managing of policies which specify rules using simple policy languages. Who can access what data and for how long, etc. In summary, Auth server enables asynchronous authorization grant. In terms of APIs, the authorization server supports APIs to carry out the above functionality. It supports APIs to request access tokens, to revoke access tokens, to audit access tokens. It supports APIs to set, update, and list access policies. Similarly, it provides token introspection APIs for token validations. IUDX authorization grant flow actually is inspired by UMA 2.0 grant flow. And the tokens that are used for access, these are JWT tokens, and for authentication, OIDC tokens are used. In summary, it provides simple set of APIs to automate consent of data providers. Finally, we discuss the data access service. IUDX Resource Server implements this data access service. It is essentially the data plane. It supports data access using APIs and subscriptions. It provides compliance. It ensures compliance with the data access policy. And it also supports data ingestion by providing publish endpoints and adapter and connector registration APIs. In terms of design, IUDX Data Access Service is designed in a distributed fashion. That is, multiple resource servers can exist by design, and these can also be implemented by external entities as long as they comply with the data access policies and support the data access API supported by IUDX. Any external resource server can fit into the overall IUDX system. In terms of IUDX data APIs, the APIs supported are search and count. In search, spatial, temporal, and attribute searches are supported. In spatial, circle, polygon, bbox, line string modes are supported. Temporal, between, before, after a certain time range are supported. And similarly, a complex combination of these searches are also supported. In terms of subscription, currently streaming is supported in IUDX. There is a plan to include callback functionality in future. IUDX data access APIs are harmonized with HC and GSI LD specifications for data access. Now, HC and GSI LD is a data access standard from EU, European Union, and this alignment is very useful as it helps in application ecosystem portability across the two widely separated geographical areas. So to summarize, we looked into the three core services of IUDX: catalog service, data access service, and authorization service. And here we have listed down the Open API pages for each of these services that list down all the APIs supported by these services. We would like to mention that IUDX and BIS, Bureau of India Standards, have collaborated to standardize IUDX interfaces, and these specs are available as India Standard 18003. In particular, the part 2 of this standard deals with API specs, and currently a compliance spec is also being developed. Now we look into some interaction flows where we will look how the stakeholders interact with these different IUDX services. First, we look at the scenario where a consumer wants to access data for a protected resource. Here we assume that in step 1, provider has already uploaded meta info into the catalog. In step 2, the consumer discovers the resources of interest using catalog search APIs. In step 3, which is out of band, the consumer requests access grant from the provider in case the access grant does not exist. If the provider and consumer agree, then the provider sets a policy for consumer in step 4. It uses the client ID and client secret, which is given to the provider at the time of registration, to authenticate with the auth server while setting up of the policy. In step 5, the consumer requests access token for a given resource from authorization server, again using the consumer's client ID and secret, which is given at the time of registration. Since a policy exists, which has been set in the step 4, the authorization server responds back with the token for accessing the resource. The consumer then in step 7 gives a resource ID and the token which it got from authorization server to resource server. The resource server now analyzes the token, and for that it can either decode the token if it's a JWT token, or it can perform a tip like in step 8 with the authorization server using the resource server certificate. The access can be allowed or denied based on the validity of the token. However, if the token is valid, then as a last in step number 9, the requested data is given back to the consumer, which completes the whole flow of getting access to the data from a protected resource. Next, we look at the data ingestion view. We look at a scenario where a provider wants to publish data using an adapter program or an adapter application. Again, here we assume in step 1, provider has already uploaded meta info into the catalog. In step 2, it sets access policy for adapter to be able to publish data for its resource. Again, it uses client ID and client secret to authenticate with the auth server. Once it has set the policy, it informs the adapter in the out of band step 3, and the adapter then in step 4 requests the token for publishing data for the provider's resources, and for which it provides its client ID and client secret. Since again the policy has been set for the adapter, a token is provided by auth server to the adapter which it uses in step 6 to request for adapter registration with the resource server. Now, the resource server again takes the token and analyzes it and performs a tip with this token with the authorization server. And if it's a valid token, it provides a publication URL along with some credentials, for example, the credentials for the data broker channels. The adapter then connects to the publication URL and publishes the data. Here it is assumed that while publishing the data, the provider has made available to the adapter all the credentials that are required to pull data from a downstream server that is being pushed into the resource server. So these two flows will provide a good view of how the stakeholders interact with the various services provided by the data exchange. IUDX, which is currently deployed. Open APIs and data models we've already discussed, and similarly we have already discussed how the whole architecture or whole implementation is consent driven. In terms of implementations, certain other principles have been diligently followed. So secure by design, that is, security considerations are part of the design right from the start, and all the best practices have to be followed. It is an open source implementation where we use leading tools and technologies from the open source industry. It is cloud deployable, designed for cloud deployment and utilize the state-of-the-art cloud infrastructure. Another design principle used is scalable and elastic by design. Upfront considerations for scalable and elastic designs for all the software components. These are not to be an afterthought, but have to be thought right from the beginning. The architectures that have to be chosen are service-oriented, which can be scaled up and down without affecting the other components. Similarly, the implementations have to be cloud agnostic, cloud service provider agnostic. That is, we should not be locked. There should not be a cloud service provider lock-in, and we should be able to move from one cloud service provider to another as far as the deployment of IUDX is concerned. We would like to just put down a view of technology stack, open source technology stack that we have used, where API services have been followed. We have used Vertex framework for this. For data ingestion, we use Apache Flink, Logstash. For data stores, we use Elasticsearch, PostgreSQL, Redis Cache. For deployment, scaling and clustering, we have used Docker, Kubernetes. And as a data broker, we have used RabbitMQ. I mean, we have plans to include other important brokers in future. Development and testing tools we have used again from all the open source stack, such as Zap, Postman. API gateway and security, we have used Nginx, Keycloak. Finally, logging and system metrics, we've used Micrometer, Loki, and Prometheus stack. So to conclude, IUDX is a data exchange service that hosts and manages meta information about resources and facilitates their discovery. That is where the catalog services come in, facilitates the exchange of data via resource server and data access service, and facilitates authentication, authorization, and accounting mechanisms, which are covered in the auth server. Defines two main participants or stakeholders, data providers, consumers, and defines the flow of information between them, providers, consumers, and catalog, consumers and resource servers, providers, consumers, resource servers, and authorization service. With this, we conclude this session. Thank you for listening.